If you've ever dealt with spaghetti code that works flawlessly on day 1, but then completely crashes by day 30, well, this explainer is exactly what you need. Let's dive right in and demystify some really complex Salesforce architectural decisions by deconstructing a production-ready solution called NimbusPoint. Whether you're an admin trying to understand the why behind the code or a seasoned developer fine-tuning your enterprise patterns, we're going to break down how to build a system that doesn't just survive in a sandbox, but actually thrives at scale.
We'll be following the journey of a single data point today, all the way from the user interface down through the Apex security boundaries and right into the asynchronous backend. We'll cover everything from stalled deals and self-reinforcing architecture to security boundaries, governor limits, LWC reactivity, and finally, designing for future scale.
So let's kick things off with Section 1, stalled deals and missing data. Before we look at a single line of code, we really need to ground our architecture in the actual business pain we're solving. Let's be completely honest for a second. Salespeople aren't exactly famous for their love of data entry, right? The absolute chaos of reps using random notebooks, sticky notes, or whatever else is lying around directly causes the business to lose visibility into inactive, high-value deals. You end up with totally inconsistent logging, ad hoc notes, zero structure, and missing native roll-ups. The CRM literally has no idea a rep ever spoke to anyone. And because of that, you get invisible stalled deals. Massive, high-value opportunities go cold, and nobody knows they haven't had activity in 2 weeks until it is way, way too late. All right, moving into Section 2, a self-reinforcing architecture. Let's look at a single, elegant fix for both of those massive business headaches. The real beauty here is that both of those problems share the exact same fix. When a rep logs a note via a Lightning Web Component, a standard task is instantly created and linked directly to the opportunity. And because it's a standard object, Salesforce natively rolls up that last activity date. No custom triggers to maintain, no messy formula fields. It just works. Instantly, the UI updates, and critically, a daily batch job silently drops that newly active deal from tomorrow's inactivity alert. Basically, good rep behavior automatically silences the system's nagging notifications. Log a note, and the system heals itself.
Now, for Section 3, security and service boundaries. We're crossing the trust boundary into the apex layer, where structural separation is absolutely critical.
We're using a really strict handler and service separation pattern here. The call notes handler is your UI boundary. It carries that public with sharing keyword, meaning it strictly enforces the running user's record-level access. Zero business logic lives here. It just delegates to the call notes service, which uses public inherited sharing for the actual domain logic, validation, and DML execution. Why? Because inherited sharing allows the service to adapt. If called by a secure UI, it runs securely. If called by an automated system batch, it adapts to that system context. Think about what happens if you forget a sharing keyword entirely. You've just created a silent security risk. The system defaults to without sharing, opening a massive backdoor. This is exactly why we strictly separate that secured UI handler from the flexible service layer. And that brings up a really crucial point. Client validation is a UX tool. It is not a trust boundary. Instant browser feedback is awesome for users, sure, but true security requires unbreakable server-side validation. You can have the most beautiful red error borders on your Lightning Web Component, but anyone hitting your Apex endpoint directly via Postman completely bypasses all of that. The service layer is your true trust boundary. Validating things on the server against an Apex set gives you lightning-fast O1 membership checks. So if someone tries to inject garbage data, the server rejects it instantly, and no database operation runs until all those strict server-side checks pass. Welcome to Section 4, Mastering Salesforce Governor Limits. What's super fascinating here is how every single number in this codebase acts as a deliberate platform defense mechanism. Take the number 50. This exact number is our batch chunk size, and it is quite literally the linchpin of our entire governor limit strategy. Why not 100? Why not 200? Because in Salesforce architecture, you don't just build for the happy path, you build to survive the limits. By locking that chunk size at exactly 50, we create a massive 3x safety margin against the platform limit of 150 custom notifications per transaction. If you try to process 200 records and hit 151 notifications, boom, the entire transaction fails. At 50, we guarantee a single failure never aborts the batch. Plus, our architecture strictly enforces 0 SOQL queries inside execution loops and exactly 1 DML statement per note creation, period. No matter how many notes a rep creates, the database cost is completely locked down. Now, in a world of clicks, not code, you might actually be wondering, why choose Batch Apex over a scheduled flow here?
The answer comes down to a really hard Salesforce platform limitation regarding activity objects.
Flows just cannot efficiently handle a set-based exclusion across two different activity objects without looping, which absolutely destroys your governor limits. Because SOQL doesn't support semi-joins on activity objects, you can't just query ID not in select what ID from task, we use this powerful two-step query pattern in the batch start method. We calculate the 14-day cutoff, query tasks and events to collect those what IDs into a set in memory, and then use database.get query locator to filter our opportunities. The genius of the query locator is that it streams records in chunks. It can handle up to 50 million records without blowing up your Apex heap limit. We pre-calculate our exclusions once and totally avoid blowing up our limits.
But watch out, there's a trap here. What if it's day one of a brand new org, and there is absolutely zero recent activity? Your exclusion set is completely empty. Passing an empty set to an ID not in query throws a fatal SOQL syntax error at runtime. Adding a null placeholder to that empty set safely bypasses the error. This one little line of code is the ultimate edge case defense, saving you from a totally catastrophic runtime error on day one of a fresh production deployment. Let's transition over to Section 5, LWC Performance and Reactivity. We're heading back up to the client side to see how this system stays blazing fast. To keep things snappy, we use the cacheable flag on our wired read methods, letting Lightning Data Service serve repeat calls straight from memory instantly. But since cacheable methods strictly cannot perform database writes, we use imperative promises for all our DML operations, like inserting or deleting a note. Then, we use the register refresh handler for event-driven updates. So if a user saves a quick action, this handler catches the platform event and refreshes our custom tile data. Throw in some immutable updates with object.assign, and the result? The UI updates instantly across components, completely eliminating the need for a clunky manual page reload. And finally, Section 6, Designing for Future Scale. Knowing where the edge of your architecture lies is way more useful than pretending it's perfect, right? So let's look at how we'd scale this for the enterprise. Right now, we're using a 1-second polling interval as a fallback to refresh the UI. In a demo org, sure, that's fine. But with just 50 concurrent users, you're looking at 180,000 Apex calls an hour. For massive concurrent user bases, we'd swap that costly polling for real-time platform event subscriptions. We'd also move our magic numbers, like the hard-coded 14-day inactivity threshold, into custom metadata types, so admins can tweak them without a code deployment. We'd replace that fragile subject string parsing with a dedicated custom picklist field, and restructure our data model to dodge that heap limit risk entirely. Speaking of limits, I'm going to leave you with this provocative thought to evaluate in your own orgs. If you have 10 million task records, what breaks first in your batch? The answer is that your in-memory exclusion set will hit that 12 megabyte Apex heap limit, and your batch is going to crash before processing a single opportunity. The real enterprise fix? An indexed custom date field on the opportunity itself, updated via a trigger, totally eliminating the need for a memory-heavy set-based query entirely. As data scales into the millions, mastering these Apex, heap, and query limits is the true mark of a Salesforce architect. Thanks for joining me on this explainer. Keep building and keep scaling.